Okay, so at the moment we have an issue with our thumbstick aim. We can push the right thumbstick in a direction and we can make the character face the direction that we're pushing the thumbstick in, which is great, but at the moment when we release the thumbstick, our character will always snap back to facing forwards. Now we want to prevent the character from doing this when we release the thumbstick, and the solution to this is to set up a thumbstick dead zone. Currently, we rotate the character based on our thumbstick input, but we only want to rotate the character when these thumbstick input values are large enough. When I say thumbstick dead zone, I really just mean a range in which our thumbstick input is ignored. So we're only going to rotate the character when the values of our thumbstick input are large enough or high enough, and if they are too low, we won't even bother calling the function that rotates our character. So how do we get started here? Well, we're going to open up our marine blueprint, and inside our update player aim function, we can actually remove the print string and the float to string conversion here. Let's just make sure that we hook up our execution pin again to the set control rotation function. Now we're going to proceed by creating a new function, and this function is going to check if our thumbstick input values are above the thumbstick dead zone. So we can name this is thumbstick above dead zone. And we're going to start by calling our thumbstick aim up axis value, and we're also going to get the thumbstick aim right axis value. Now what are we going to do with both of these values? Well, we're going to make a vector, and it's going to be a vector 2D. The aim up is going to be the x value, and the aim right is going to be the y value. Now a vector 2D doesn't have a z value here, so we're just working with x and y. With the return value of our vector 2D, we're going to drag this out, and we're going to call the vector length function. We're going to grab the vector 2D length here. So this returns the length of our vector. Now feel free to print the return value of our 2D vector length function as a string, just like I'm doing here. And as we can see, when we don't push on the thumbstick, the length of our 2D vector is going to return 0. But as we push the thumbstick in any direction, the value returned is going to be 1 or above. And if we gently release the thumbstick, we can start to see that the values decrease all the way down to 0. And the 0 is where our issues come in. If we push right on the thumbstick, the character faces the right direction, and as we gently release, we can see that he still faces the correct direction, but as soon as we hit 0, the character snaps back to facing forwards. And this happens in any direction as well. We're only going to allow our character to rotate if the length of our 2D vector is over a particular value. So we're going to compare the length of the vector to another float. By doing this, we are making our own thumbstick dead zone. And I want you to try finish off our function by yourself. So I want you to create a variable named thumbstick dead zone, make it a float, and give it a default value of 0.5. Now we're already getting the length of the 2D vector we just made in our function. We want to do a comparison with this. We want to compare the length of the 2D vector to see if it's greater than the thumbstick dead zone. Once you've got this far, we're not going to write any more code in this function. Instead, we're just going to return the result of this comparison as an output pin on the function. So I want you to do this as well. And just to wrap it up, look over the code for the function, check the function name, look at what it's doing. Should the function be impure, pure, or pure const? So pause here for a few minutes to set up the rest of this function. Okay, so with the length of our 2D vector, we can compare it to see if it's greater than a value by dragging it out and putting in the greater than symbol, and we can get the float greater than float. Now, what do we want to compare it to? Well, we want to compare it to a value that will be our thumbstick dead zone, which we currently don't have. So we're going to create it. Let's create a new variable named thumbstick dead zone, and let's change the variable type from a boolean to a float. Now we can hit compile to set the default value, which is going to be 0.5. And we can plug it straight into the second input on this comparison here. So this now asks the question, is the thumbstick input greater than the thumbstick dead zone? And the answer to this will be returned in this Boolean pin here. We want to output this on our function. But there's no return node inside our function here. To get one, we can right click and scroll all the way down, and we can find this add return node selection here. And if we select this, it adds the return node. And we can drag and drop our Boolean onto the return node to create a return value. And we can hook up our execution pin. And this is our function, or the code for our function, complete. But now comes the question, should this function be impure, pure, or pure const? Well, by looking at the name of this function, we can see it's named isThumbstick above dead zone. We can tell that it's named in a way that's stating its intention. It's asking a question or doing a calculation. So just by looking at the name, we should be thinking that this function isn't going to affect the state of our blueprint class in any way. But also by looking at the code of our function, we can see that there's not much going on in terms of the execution flow. It's certainly not setting anything or affecting anything in the world. Therefore, our function can be pure const. We ask the question, is the thumbstick above the dead zone, and the function gives us the answer. Now this is our function complete. We can compile and we can close this tab because we don't need to change any of the code for this anymore, and we can come back to our update player aim function. Now we said that we only want to change the rotation of the character, and remember we do this by setting the control rotation of the player controller. We only want to change the rotation if our thumbstick is above the dead zone. So we're going to call our isThumbstick above dead zone function that we just wrote. We can drag it onto the graph. We can hold down B and left click to place a branch on the graph. We can use our function as the condition. We can hook up the execution pin to this. So we can see, is the thumbstick above the dead zone? If it is, we can then set the control rotation for the character. Awesome, so let's hit compile and let's save. Let's come back to our level and let's try this. The character faces forwards with no input on the right thumbstick, but we can push the right thumbstick in the direction that we want the character to turn. But if we release the thumbstick now, the character no longer snaps back forwards. So the thumbstick aiming is now working correctly. Awesome, this is really good progress. Now there's not actually anything more we need to do in terms of the thumbstick aiming, but we do want to start thinking about mouse and keyboard input. So we're going to start tackling this in the next lesson. Hey, and welcome to this lesson where we're going to make our character aim in the direction that we move our mouse in. We're already doing this with the gamepad, but we want to make our game playable for those playing with mouse and keyboard. Now, our mouse isn't like a gamepad. On a gamepad, we can hold a thumbstick in one direction, but to get the same result with a mouse, we would have to continuously move a mouse in a direction to get the same result as pushing a thumbstick. So we're going to have to write some slightly different code for handling the mouse aiming for our character. So we're going to disable the thumbstick aiming code we wrote in the previous lesson, just for now while we start writing the code that relates to our mouse aiming. Then we'll see in the next lesson how we can combine both the mouse and gamepad aiming together. But our objectives for this lesson are to create a function that returns the mouse velocity, and we want to create a mouse dead zone, similar to how we created a dead zone for the right thumbstick. Then we only want to rotate our marine if the mouse is over the dead zone. So we're going to be working inside the update player aim function within our marine blueprint. And we want to start by breaking off our thumbstick aiming code. Remember, we can break off execution pins by hovering over a pin and holding down left alt and then left clicking on the pin. Now we can move all of these nodes down that handle our thumbstick aiming. We'll come back to these in the next lesson. Now we're going to create a new pure const function. So let's hit new function and we're going to name it get mouse velocity. Let's also mark it as pure and as const. And let's just make sure that we hit compile before we start writing our code. We need to start by determining how far the mouse has moved in this frame compared to the previous frame. There's a function that already does this inside the player controller that we can call. So let's get the player controller and let's drag out from the player controller to call a function named get input mouse delta. When we hover over this node, it tells us that it returns how far the mouse has moved in this frame. And we can see it returns an X and a Y value. So it tells us how far up and down or left and right our mouse has moved. We're going to proceed by making this into a 2D vector. we can right click and call make vector 2D, and then we can plug the delta x into the x input, and then we can plug the delta y into the y input. Now to get our velocity, we need to divide this distance the mouse has moved by the time that has passed since the last frame. We're going to drag out from our vector 2D and put in a division symbol so we can divide the vector 2D. We're going to divide it by a float. So I said we want to divide it by the time that has passed since the last frame, and we can call the function that will return this value as a float. It's called getWorld delta seconds. This is what we're going to use to divide our 2D vector by. Now the output pin of this division is going to contain the mouse velocity. The final step for our function is to make sure that the function returns this value. So we're going to right click and either scroll down or just type in add return node. We can drag the pin onto the return node to make it return this value. Then we just need to hook up the execution pin, and then we can hit compile and save, and this is our get mouse velocity function complete. So we've disabled the thumbstick aiming, and we've completed the first objective of setting up our mouse aiming by creating a function that calculates the mouse velocity. This is going to help us create a mouse dead zone. But before we create a mouse dead zone, let's start setting up the code that rotates our character. Let's come back to our update player aim function. We already know how to rotate the character. We have to adjust the control rotation of the player controller. So let's do this. Let's get the player controller, and then let's call set control rotation from the player controller. And let's hook up the execution pin here. Now remember, we don't want to adjust the pitch and roll of the control rotation. We're going to take the rotator input pin and drag it out and call make rotator. This now gives us access to the roll, pitch and yaw. We're going to leave the roll and pitch at 0, and then we're only going to adjust the yaw value. The yaw is what we use for turning the character. So how do we go about calculating the aim direction when we use the mouse? Well, it's kind of going to be similar to what we did with the thumbstick aiming. We made use of this tan 2 degrees node, and we're going to use this again. But instead of getting the input values like we do with the thumbstick, we're going to make use of the mouse velocity node we just wrote. Take note that after you create a function, you can search for them in the action menu like any other function. So I'm going to bring up the action menu and call the get mouse velocity function we just wrote. And we're also going to call the tan2 function, and we want to use the version that uses degrees. We can split our mouse velocity to gain access to the x and y values that can be used for the a and b input on the tan2 function. Then we can drive the yaw rotation of our character with the return value. The tan2 function will read the mouse velocity and calculate the angle that we want our character to face. Okay, so you'll notice that it's kind of similar to how we set up the thumbstick, but let's save our work and let's come back to our level and see how this is progressing. You'll notice that it's very snappy, and you'll have to continuously pan the mouse to make the character face a particular direction. As soon as you stop panning the mouse, the character snaps back to facing forwards. It's the same issue we had with the thumbstick. As soon as we stop our input, the character faces forwards. In order to fix this, I'm going to challenge you to set up a mouse dead zone. Create a float variable for your mouse dead zone. You can tweak and tune it however you want, but for a good starting default value, I'd recommend using 20. Then create a function that will be used to check if the mouse is above the mouse dead zone. Make sure to check that it's pure const, and then inside the function, you want to compare the length of the mouse velocity to your mouse dead zone variable. Check if the length of the mouse velocity vector is greater than the mouse dead zone, and return the Boolean result of the comparison as an output pin on the function. Then for the final step, with your function complete, rotate the marine only if the mouse is above the dead zone. So pause here and follow the challenge, and remember, if you get stuck, you can always check your thumbstick aiming code. Okay, so I hope you had a go at the challenge. You should now have a new pure const function in your marine blueprint that calculates if the mouse input is above the mouse dead zone. We do this by getting the vector length of the mouse velocity, then we compare it to a new variable that I've named mouse dead zone, and this has a default value of 20. we return the result of this comparison as an output pin on our function. So inside our update player aim function, we can now check if the mouse input is above the mouse dead zone. And if it is, we then go on and set the yaw control rotation of the player controller. So now if we come back to our level and play our game, we will notice that the character will no longer snap back to facing forwards when we stop moving the mouse. However, we do have an issue here. The mouse feels very snappy. It feels pretty much unusable at this point because it's way too sensitive. So to fix this, and this will be our final step for setting up the mouse aim, we're going to apply some mouse smoothing. To apply mouse smoothing, we're going to do some interpolation. Inside the Blueprint Action menu, we can find the Math category, and within Math, we can find the Interpolation category. Now, there's many different nodes here for interpolating different types of data, but we're going to be interpolating from one rotator to another. The node we're going to use is called rinterp2. This function will simply smooth the values of one rotator to another. And this node will have to be used on tick, which is fine because our update player aim function is called on tick. But I just want to be clear that this function wouldn't work as expected if it wasn't called every frame. We just have to provide the world delta seconds and how fast we want the smoothing to be. So inside our update player aim function, instead of just setting the control rotation with our mouse aim calculation here, we're going to break off the make rotator and move all of this down a bit. And we're also just going to move these other two nodes along a little. Now with the player controller, we're going to get the control rotation. So every frame, we will know what the current rotation of the character is, and then we want to smooth this to the result of our mouse aim direction. To do this, we can drag out from the new rotation pin on the set control rotation function, and we can come to the Math category, and then the Interpolation category, and we can grab the rinterp2 function. So we want to interpolate from our control rotation to our mouse aim direction every frame. Let's just move these nodes a bit closer. Now for the next pin, we have the delta time. We can use the get world delta seconds function for the delta time input. And the interp speed is going to control how fast the smoothing is going to be. The higher the value, the faster the smoothing, and the lower the value, the slower the smoothing will be. But we're not going to hard code in a value here. We might want to easily tune this, so we're going to promote this pin to a variable. We're going to call this mouse smoothing strength. When we compile, we can set the default value of this variable. I'm going to use the value of 7, but you can tweak this as you need to until you feel comfortable with your mouse smoothing. Now let's compile and save our work for the final time for this lesson. And this is all our code for our mouse aiming, including the mouse smoothing. It's a bit messy, but we'll be cleaning up all of this in the next lesson when we combine the mouse and the thumbstick aiming together. But for now, let's come back to our level and let's see the result of what we've got. Okay, so this is feeling way more comfortable with the mouse now. It's no longer extremely sensitive, and the character is smoothing towards the mouse aim direction. Awesome, so our mouse aiming is working great now. We just need to clean up our code and find a way to toggle between mouse input or gamepad input for the aiming. So we'll be tackling all of this in the next lesson.